Hello everyone, welcome. This is the first lecture in your course Mastering Ansible by Avionics. My name is Ahmed, and in this section 1 of this course, we are going to discuss what Ansible is and how to install it. So first of all, let's discuss software provisioning evolution, how software used to be provisioned in the past and in the near past and currently. Long ago, there used to be a clear distinction between a software developer and a system administrator or an operator. The role of the software developer was just to test the code that the developer has written, while the role of the second was to avail the necessary infrastructure and deploy the application. And then after some bugs perhaps have been introduced, after some new requirements are made, the life cycle is repeated. The software returns to the hands of the developer to make any required changes and then hand it over to the operator or the system administrator to deploy it and to avail the necessary infrastructure, perhaps for a new environment, and so on and so forth. The life cycle continues until the software is finally released. And as time passed, technology evolved, and as a result, the number of servers that need to be managed increased significantly. Currently, we are in the age of virtualization. Actually, virtualization is not a new term here. It has been also perhaps an old one. However, it has in the past maybe 5 years evolved significantly with the advent of what was called cloud computing. The idea of launching your VM in the cloud, launching it on a platform like Amazon or Google or Microsoft Azure and all those platform providers. They provide you with infrastructure as a service. You just give them requirements through a web page, for example, and then launch an instance of your virtual machine in the cloud. Manage it the way you want, install the necessary software, do whatever coding you need, and then perhaps you can destroy it and create another one, or end the whole operation. You can do whatever you want. It's just your machine in the cloud. So this is an important improvement and an important stage of evolution in software development, because now the life cycle of an application is faster than ever. And with the advent of new software methodologies like agile development, if you have heard this term before, it is a form of software development where the application lifecycle is kept at the minimum. The application lifecycle should last no more than a couple of weeks, after which the application is released for testing. Testing, of course, reveals bugs or new features that need to be installed, new components that need to be incorporated into the application, so it returns back to the developer to do the necessary work and then deploy it again and over. This life cycle, or this iteration as it is sometimes called, should not last more than 2 weeks. So imagine how system administrators should be working hand in hand with developers to keep this life cycle to the minimum. To address those necessities, aiding tools arose to facilitate and shorten the application lifecycle, and a new buzzword surfaced. Perhaps you have heard it before. It's called DevOps. So what is DevOps anyway? I know you have heard this term before. Some of you may have an idea about it. Some of you may be seeing it for the first time. So for all of you, let's have a quick discussion of DevOps right before we delve into the world of Ansible. DevOps is one of the terms for which you will hear different definitions depending on whom you are asking. Just like big data and cloud computing, it's just one of those terms that have been heard frequently in the last couple of years. DevOps in its core is a concept that eliminates the difference between developers and operators, and of course hence the name. Both teams, developers and operators, should be able to use a set of tools that helps shorten the application lifecycle and ease the overall development, testing, deployment processes. DevOps tools have many categories. Let's have a quick example. You have version control like Git. We have also Bitbucket and other version control systems. Continuous integration like Jenkins. Testing like JUnit. Provisioning and configuration management like Vagrant, Chef, Puppet, Salt, and of course Ansible. So along came Ansible. Through all this buzz, through all these tools and categories, we have Ansible. So what is Ansible? If you are like me interested in the name origins, Ansible, as you have probably guessed, is not an English word. If you look at a dictionary, you find that it stands for nothing. There is no word in English that is called Ansible. But it has its roots, and these roots actually are literary ones. Ansible is a fictional device that was capable of transmitting messages at a speed faster than light. The sci-fi author who first coined it stated that it was derived from the word answerable. It was first introduced in a novel that was written in the 1960s, and It introduced a device, of course a fictional device, that was able to transmit messages in a speed that is faster than light. So it is very fast, it is very responsive, and as you're going to see, those are one of the real features of Ansible as a software application that we're going to discuss in this class. It has the features of this fictional device, and hence came the name. Ansible is a configuration management and IT automation tool that was released in 2012 by Michael DeHaan, who was looking for a tool that could combine the roles done by disparate tools: configuration management, server deployment, and sending arbitrary commands to a remote server like through SSH. If you are a system administrator, and I assume you are, you've probably come into situations where you want to run a quick command on a remote system. Let's say, for example, that you wanted to add a new entry to the /etc/hosts file of a dozen Linux servers. You'll probably go to your terminal, type in SSH, or maybe construct a for loop in your shell, and through this for loop you issue SSH commands that will connect to each of these dozen servers and add an entry to the /etc/hosts file. This is just sending an arbitrary command through SSH, and this is done by almost every system administrator I have known to be using Linux or Unix. Ansible does all this without the need to install an agent or open extra ports on your servers. So Ansible, as you might guess by now, is a configuration management tool. It helps you configure a server, run arbitrary commands on the server, and ensure that the server reaches a required state. A tool that does this is referred to as a configuration management tool, or a CM tool. So I might hear you asking, and what's wrong with plain old shell scripts? Why don't I just use a shell script to do the tasks that I need, to configure the server the way I need it, to ensure that the server or the node is in the state that I require? Well, if you are a veteran system administrator, you will sure be more comfortable with the way you manage your servers using SSH and shell scripts. However, in the era of cloud computing and the need for instant provisioning, shell scripting might fall short when addressing, for example, the following. Of course, the couple of factors that I'm going to list here is just an example or a sample of what shell scripts fall short ahead of in real life, and as you're going to learn about Ansible, and as you will learn later when you examine different DevOps tools, we'll see that configuration management tools do much more than that. But for example, change documentation. While shell scripts allow you to add comments to your commands, this is still far from being a change management document. Change management is very important, and if you are in a medium to large enterprise, you are already aware of the need of change management processes. If you have hundreds of servers, and in the era of virtualization, this is a very, very normal number in a large or medium or even small enterprise. If you are not aware of the changes that are regularly done to those servers, and changes do happen and are required, so if you're not aware of those changes, if you don't document those changes, you might find yourself lost between the different behaviors of servers that are supposed to be identical. For example, if you have like 5 web servers and all of a sudden you discover that one of the servers is not behaving as the rest, let's say that you have, for example, PHP version 5.5 or 5.6 installed on those 5 servers to solve a certain bug that was addressed by this specific version of PHP, and then all of a sudden you find that one of the web servers is still having this bug, and you check on the version of PHP installed only to find that it's an older version than the one installed on the rest of the servers. Let's say, for example, it is 5.4 or 5.3. So you wonder, why is this server having this version of PHP and not the correct version as the rest of the servers? And after some troubleshooting and after some wasted time trying to figure out what has changed, you discovered that you or one of your teams was trying to test something, or was trying to make a workaround for some issue that arose on this web server, so he or she decided to downgrade the version of PHP to a lower version, and because this change was not documented, it caused chaos. It caused wasted time and effort, it caused unexpected behavior, it caused losses. So this is one of the needs why a change management policy is required to be in place in each and every organization, no matter how large or small it is. With Ansible and with configuration management tools in general, documentation is inherent, as we're going to see, in the way those tools work, and specifically in Ansible. You're going to see that documentation is part of the instructions file that you're going to work with Ansible. The second factor is something called idempotence. And don't be intimidated by this term. It's just a fancy term that is used to describe the ability of operations to be run multiple times, yet yielding the same results. Let's say, for example, that you want to ensure that the Apache web server is installed on the server. This is a requirement that you want to ensure that the web server is installed on all the servers that you manage. So it's as simple as running yum-y install httpd, or if you're running Ubuntu, it may be apt-get install apache 2. Okay, so it's very easy. Apache web server has been installed. But then a couple of weeks later, you want to ensure that all the servers are having the correct version of Apache web server, and that this package was not removed either by accident or deliberately on one of the servers. So you run yum-y install httpd again, or apt-get install apache 2. However, running yum or apt-get again will do the same steps that was needed to install the package, whether it is already installed or not. It is going to go query the repository sources and grab the version of Apache or HTTPD, and only when it starts installing it, it will discover that a package is already installed, so it will give you a warning or a message that notifies you that this package is already installed. But you needn't go through this. You need a shell script. You need something that tells the script not to go and run the yum tool or the apt-get tool if this package is already installed. You needn't waste time downloading metadata from the repositories or building up the list of packages that is needed for either yum or the apt-get package manager to work if the package is already installed. It has to be just skipped. This step has to be just skipped. So this is called idempotence. You need to run a command, and no matter how many times this command was run, it should produce the same results. And that is exactly what configuration management tools do. As you're going to see later in this class, Ansible and configuration management tools produce scripts that will yield the same results if run either once or thousands of times. It will not run into errors because, for example, it is trying to do something that has been already done before. It should be aware that if something has been already configured, or like for example a package has been already installed, or a file has been already written, or a permission has been already set, it should not try to make this again. It should not try to duplicate this work again. And it should not fall into any errors. This is another thing that shell scripts fall ahead of. Of course, you might argue that shell scripts can have the necessary commands and tools. A clever shell script editor can write commands and perhaps functions that does all those checks automatically for us. But as we're going to see, this makes your script nothing but bigger and harder to maintain. So as you can see here, this is the advantage of using a configuration management tool. So as you can see here, those are just two of the advantages of using a configuration management tool. And as we work in this class with Ansible, you're going to see that it is much more efficient than using a plain shell script. And that brings us to the end of this lecture. In the coming lecture, we are going to start by comparing Ansible to other tools in the market. We might also start installing Ansible on our test machine, so see you next.